Determine the equation of a line passing through the point 0, 2 and making an angle 2 pi over 3 with the positive x-axis. Also, find the equation of another line parallel to it and crossing the y-axis at a distance of 2 units below the origin. Now let's try to understand the problem graphically first. So what we'll do, we'll consider the coordinate axis. We'll begin by first considering a point A on the y-axis which has the coordinates 0, 2. Now we're going to pass a line through this particular point in such a fashion that it makes an angle 2 pi over 3 radians with the positive x-axis. So this is so 2 pi over 3 radians. If it ever feel confused, so always convert it to degrees. In degree measure, it's simply replace the value of pi with 180 degrees. So we have 2 times 180 divided by 3, so that corresponds to 120 degrees. So this is going to be the degree equivalent of 2 pi over 3 radians. Now 120 degrees means it's an obtuse angle, an angle greater than 90 degrees. So here we'll make a judgment call. That means we are going to consider the line in such a way that it makes an angle 120 degree with the positive direction of x-axis. So here we will draw the diagram in such a way we can assume that this particular angle is 120 degree. We don't have to be accurate here. Okay. Now we have a line which passes through a point 0, 2 and it makes an angle 120 degree with the x-axis. So what we can do, we can use the point slope form to obtain the equation of this particular line. So let's quickly recapitulate the point slope form of a line. So the point slope form of a line tells us that if we know a point through which a particular line passes, let's say the point is given by x1, y1, and we also know the slope of that particular line. Then using these two information, we can obtain the equation of the line which is given by y minus y1 equals to the slope m multiplied to x minus x1. Fine. Now in our case, we have the point A. This will correspond to x1, y1. However, we don't have the slope. But that's not a big issue because we are given the angle that the line makes with the positive direction of x-axis, which is 120 degree. Using this information, we can easily obtain the slope of the line. So here, the slope of the line, which we'll denote by m, that will be given by tangent of the angle that the line makes with the positive x-axis. So that's 120 degrees. So now let's calculate the value of 120 degrees. So 120 degrees can be also expressed as 180, but we have exceeded 120 by 60 degrees, so we're going to subtract 60 degrees from it. There's a reason behind it why we're writing in this fashion, because 180 can be also expressed as 2 times 90 degree minus 60 degrees. So here 2 times 90 means it's an even multiple of 90 degrees. So whenever we have an even multiple, so tangent is going to stay as the tangent function, but the new angle is going to be 60 degrees instead of 120 degrees. Now we'll also have to take care of the sign, because here the number 2 represents that we are in the second quadrant. Now in the second quadrant, this is the second quadrant. Here the tangent function is always negative. So that means our result should be negative tangent 60 degrees. Okay. Tangent of 60 degrees, that has a standard value of square root of 3, which means that the slope of the line comes out to be negative square root of 3. And this value makes perfect sense because we noted whenever the angle that the line makes with the x-axis is an obtuse angle, in that case the slope always comes out to be negative. Okay, so now we have the slope of the particular line. We also have the point being A, which is 0, 2, through which the line passes. So we can obtain the equation of the line using the point slope form. So now we have y minus y1. So here y1 will correspond to the y coordinate of point A. So that's simply 2. This will be equals to the slope, which is negative square root of 3, multiplied to x minus x1. So here x1 will correspond to the x coordinate of 8. So that's 0. So we have y minus 2 equals to negative square root of 3x. Or rearranging the terms, we get positive square root of 3 times x plus y minus 2 equals to 0. So this is going to be the required equation of the line which passes through the point 0, 2 and makes an angle of 120 degree with the positive x-axis. Now, in the next part, we all have to find out the equation of another line which is parallel to this same line. Now, We don't have to worry about the slope anymore because we know for a fact that two parallel lines have equal slope. So the next line whose equation we need to find out is going to be parallel to it. So it's going to have a slope equals to negative square root of 3. Now it's given here that this particular line crosses the y-axis at a distance of 2 units below the origin. So let's say this is the particular point B. So B has the coordinates 0, -2 since it is crossing the y-axis in the negative direction. So here we will consider a line that passes through this particular point B and also parallel to the previous line. So we have this line which is represented by the yellow color. So this particular line has a slope equals to negative square root of 3 because it is perpendicular to the original line, and it passes through the point B 0, -2. So let's use the point slope form. So now the equation of the line will be y minus y1. So this time the y1 will be -2 equals to the slope, which is negative square root of 3 multiplied to x minus x1. So x1 will be 0. So we get y plus 2 equals to negative square root of 3x, or rearranging the terms, we simply get square root of 3 times x plus y plus 2 equals to 0. So this is going to be the equation of the other line which passes through the point B 0, -2 and is parallel to the previous line. In other sense, we can say this particular line is also making an angle 120 degree with the positive x-axis.